So in this one we've got example 3.5, which is a nice little circuit. We've got a dependent current source. We've got a independent voltage source. We've got like that. So that looks like ours, and we got our 10 Ix equals 4v1. We've got 1, 1, where's this, 2, 2, and 3. And this from here to here is v1. And that looks good. So let's start. Mesh analysis. We're going to do a nice little mesh here. We're going to do a mesh down here, which is going to call I1. We're going to do a mesh over here, I2. We're going to do a mesh also all the way through here. I'll call this I3. Okay, that's how we set this sucker up. Now let's solve it. Mesh 1. Mesh 1, we're going to look at, what do we got? We got I1, and then we got the things that touch it, which is 1 plus 2. 1 plus 2. And now we've got minus, let's do the I2. Anything touch mesh 1, you get I2 going through this one, so it's negative because it's going backwards. We got an I2 times 2. Cool. And what else do we got? We got this, we got that. What else do we got up here? We got an I3 minus I3 times 1, right? Because it's going backwards too. And anything else in this for this main one equals 10. Our supply, because these are all subtracting from the supply. Okay, that looks pretty good. We can simplify that out a little bit more. 3I1 minus 2I2 minus I3 equals 10. Save that. Take it to the bank. Alright, let's do the next one. Mesh I2. This was I1, so let's do mesh I2 next. Mesh I2. Going to do I2 times 2, 5, 6 minus the one that it shares with this, so that's 2I1, I1 times 2 minus the one it shares with it, so this is I3 times 1, and there's no power supply in there, so that's just going to equal 0. So we can simplify this one out a little bit more to minus 2I1 plus 6I2 minus I3 equals 0. Cool. Grab a sip. And next we're going to go down. We're going to do mesh I3. And we're still on the screen. Good. Mesh I3. We're going to do the same thing that we did before. Mesh I3, let's look at this. So I3 is going to equal, well, I3 equals Ix. And what does Ix equal? 4v1. Alright, let's write this down. This is different. I3 equals Ix equals 4v1. Alright, that's cool. Now we need to get V in terms of I, because all these other are in terms of I. So what do we do? V equals IR. So we can do let's look. We got V1 over here. This is the one we're looking at. We've got the difference between this one and this one with the resistance. V equals IR. So V equals IR. Our V1 is going to equal our I1 minus our I2. I1 minus I2 times our resistor in the middle, which is 2. So V1 equals I1 minus I2. So this is going to go up into this, and that's going to be I3. So I3 equals, what is that? That's 8 I1 minus 8 I2. Good. That's our third equation. Can we see that? Yeah, we're still on the page. Woot. Okay, so 3 equations, 3 unknowns. We're ready to solve. Let's write this sucker down. We get I1, I2, I3, number. Got I1, got I2 equals, so our I1, we've got 3 minus 2 minus 1, 10. 3 minus 2 minus 1, 10. We've got this one, minus 2, 6, minus 1, 0. Minus 2, 6, minus 1, 0. We've got down here, what is this? 8 minus 8 minus 1. 8 minus 8 minus 1, 0. Matrix A minus 1 times matrix B equals answer. And we're going to solve this out, and this is going to be 10, 0, and 0. I1 equals 10, I2 equals 0, I3 equals 0. No, that's wrong, that's wrong, that's wrong. Sorry guys, I'm reading the wrong notes. This is 14 minus 10, and minus 32. I knew that was wrong because this is not going to equal this output because these values are not, we have values in there, so this is not going to happen. So minus 14, 10, minus 32. So minus 14 equals I1, minus 10 equals I2, minus 32 equals I3. And now if we're looking for Ix, we can go back over here, and I3 equals Ix, we make that a little clearer, equals Ix, done. That one's solved.